It's Professor Nugent here. Let's discuss the instrumental variables test for the endogeneity of an explanatory variable. We're going to do this test because we want to know whether we really need to do instrumental variables for some variable that is endogenous. Is the variable really endogenous that we need to look for an instrument? Consider a structural equation y1 equals beta naught plus beta 1 y2 plus beta 2 z1 plus beta 3 z2. And recall that the best linear combination of the instruments for y2 partialed out the part of y2 that was exogenous, so uncorrelated with u1, and left aside the part of y2 that is endogenous within the error for u2. So we can write y2 in the first stage equation is equal to pi naught plus pi 1 z1 plus pi 2 z2 plus pi 3 z3 plus pi 4 z4 plus u2. We get an estimate of y2 hat is equal to pi naught hat plus pi 1 z1 hat through pi 4 hat z4. So this setup implies that we may use a test to determine if the part of y2 that is related to u1 through the estimate of u2, where we can write u1 is equal to delta 1 u2 plus e1, and test by including u2 hat in the equation. Alright, so the idea is y2 hat is exogenous. We should have u1 here. y2 hat is uncorrelated with u1. y2, we have y2 minus y2 hat equals u2 hat, and this is the part of y2 that is correlated with u1, and we can write the relationship between u2 and u1 using this equation. So we want to include u2 hat in the structural equation. That is, we have y1 equals beta naught plus beta 1 y2 plus beta 2 z1 plus beta 3 z2 plus delta 1 u2 hat plus u1, and then we test the null hypothesis that delta 1 is equal to 0. At an appropriate level of significance, if we can reject this null hypothesis, then we can conclude that y2 is endogenous because u2 and u1 are correlated. That's it for testing for the endogeneity of an explanatory variable. Stay tuned to the next video and we will discuss over-identification restrictions.